1, 2, 3, 4.
Sokadoa, sokadoa, sokatoa, 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 sokadoa, sokadoa, sokatoa.
Sine, opposite hypotenuse sine, opposite hypotenuse sine, opposite hypotenuse cosine, adjacent hypotenuse cosine, adjacent hypotenuse cosine, adjacent hypotenuse tangent, opposite adjacent tangent, opposite adjacent tangent, opposite adjacent. The long sides of hypotenuse and the other two sides depend on which angle you're focusing on. Pick one angle and look, there's one side that's the opposite. You can clearly see that there's also an adjacent side. Sine, opposite hypotenuse sine, opposite hypotenuse sine, opposite hypotenuse cosine, adjacent hypotenuse cosine, adjacent hypotenuse cosine, adjacent hypotenuse tangent, opposite adjacent tangent, opposite adjacent tangent, opposite adjacent.
Sokadoa, sokadoa, sokatoa, 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 sokadoa, sokadoa, sokatoa.
All right, you guys. So I wanted to play that song one more time for you because you need to just remember the trig ratios, the sine, the cosine, the tangent ratios. Commit those to memory. Know them. We're going to use them again in this lesson, solving right triangles in 9.6. In fact, we're going to be looking at the inverse trig ratios, but we still need to know those trig ratios to do that in solving right triangles. First, let's go ahead and just look at a little cartoon, a little In the Bleachers cartoon today. So we got 3 different coaches here. First, the batting coach, he says, level swing, step into the pitch. Then you got the pitching coach, he says, push off with your back leg. And then the coaching coach, so he's coaching a coach. Slouch, act all ticked off, spit on the ground. So, as you can kind of see, the coaches out there kind of look that way, I suppose. All right, so let's jump into what we're going to do here for our inverse sines and cosines and tangents. Okay, so just for the first 2 on page 270 in your extra practice, it's asking us to determine which of the 2 acute angles has the given trig ratio. So just a little bit of a review on this one. Which one has the given trig ratio? So the cosine of the angle is 24 over 25. And so let's just write it down. I know you can probably look at this and figure that out. But we have the 2 acute angles is angle G and angle F. If we start with, we got to remember the cosine is always adjacent over hypotenuse. So first, remembering that trig ratio, cosine adjacent over hypotenuse, the ADJ over the HYP. And so what that would be for cosine of, let's start with cosine of G. So from this one, adjacent is going to be 7, and then over the hypotenuse, it's 25. So 7 over 25, which is not it. So you can see we're looking for 24 over 25. So if we try cosine of F, adjacent's 24 over hypotenuse. So yes, 24 over 25. So that would be F. So the acute angle is angle F there. So we just want to write down angle F. So that's the acute angle that has that trig ratio, that cosine of which would equal 24 over 25. Then the next one, number 2, the sine of the angle is about 0.38. This one gives us a decimal. So our 2 acute angles is E and F. So we need to know, remember, sine is opposite over hypotenuse, the OPP over the HYP. And so we got to look at sine of E first. Let's go and look at E first. So that's going to be opposite, which is square root of 2 over the hypotenuse. That's opposite right angle here. It's the square root of 14. So square root of 2 over square root of 14. We would need to figure out what the decimal of that would be to see is it about 0.38. So we could do the decimal of the square root of 2 and the decimal of square root of 14 just quickly on a calculator. So 2 square root is 1.41, 14, and the square root is 3.47. And so we can look at that there, 1.41 over 3.47, or 3.74, excuse me, and then we just go ahead and just divide that. and we divide it, 1.41 divided by 3.74, we get approximately, there it is, almost 3.8, rounding it to 3.8 on that one. So that's it. So it's E. So this one is E. We don't have to even look for F because we figured out that it was E first. Okay, so on page 269 you see this core concept, and here's the three inverse trig ratios. And so you can go ahead and highlight these. These are the vocabulary words pretty much for this section. It says let A be an acute angle. So you have your triangle, your right triangle here. A is an acute angle. We don't know what angle A is, but we would end up knowing maybe side lengths. We might know some side lengths, and so when we can use the inverse trig ratio to find the angle measure. So it's just the opposite. Before we were told the angle measure and we were going to find a side length. If we know an angle measure and one side, we can figure out what other sides are using that trig ratio. But if we don't know any angles, if we don't know these acute angles here, which would be A and B, but we do know two sides of this, and we could figure out the third side, of course, with Pythagorean theorem, but we also could figure out the angles inside here with the inverse trig ratios. It's how we could figure out these other acute angles. And so we would then see that the inverse is looking like this now. It says tan with a -1, sine with -1, and so on. Still going to be the same thing. So if we go off of A, tangent is opposite over adjacent, so it's going to be BC over AC from A. Sine is still going to be opposite over hypotenuse, BC over AB. Cosine is still going to be adjacent over hypotenuse, AC over AB. And that would tell us, if we go ahead and just do that on the calculator, it would tell us what this is right here. Alright, so let's go ahead and try a couple of these on our extra practice. Okay, so they give us 4 here to try. It says let H be an acute angle. So you have a sine of H, a tangent of H. It says use a calculator to approximate the measure of angle H to the nearest tenth of a degree. If the sine of H is equal to 0.2, then we can use our inverse sine to be able to figure this out. So what we're going to start off with on number 3 is just saying, okay, the inverse sine of 0.2 would equal H. That's basically what it is. Because basically you're going to kind of like, to get rid of a sine, you have to undo a sine with the inverse of the sine. And so you're basically going to do the inverse of the sine to the sine, that would undo that, and then we do the same thing to the other side. The inverse sine of 0.2 would then equal just the H. And so that's what we're looking at. So on a calculator, let's go ahead and take a look at this. So I would type in 0.2 first on this calculator. And then I have to hit the inverse button, because here's my sine, cosine, tangent. Inverse button now makes it sine of -1, which is the inverse. And so when I hit that, well, then I get my answer there. It's about 11 point. So the inverse sine of 0.2 is 11 point to 10th, 11.5. So it'd be about approximately 11.5 degrees then. Now on the calculators in class, let's just take a look at how we would do that here. So here's our calculator we use in class. Our sine, cosine, tangent buttons are here. We would have to hit the second button, then the sine. That would give us the inverse sine, and then we would type in 0.2 and then close the parenthesis, hit equals. That would give us our answer, that 11.5 number. So that's how we would use this calculator. Alright, going back to what we have over here, same thing. We're going to now use the tangent button, but the inverse tangent button, and it's going to be the inverse tangent of 1. So just the inverse tangent of 1 will equal what H approximately is. The measure of angle H will approximately be. So going back to our calculator, we can just clear that off. I got to type 1 first on this one though. I got to put the number in, then hit the tangent, or the inverse tangent. So inverse, then tangent, and it's 45. So 45 degrees right there is that one. So I'll give you a minute here to, or seconds, to try to figure out 5 and 6. Go ahead and use your calculator and try to figure out what the cosine, or what the H is out of here. What's the angle H from these two? So go ahead and stop the video and try these. Okay, so hopefully you stopped the video, you tried them on your calculator. You should have just used your phone, I suppose, on that one. or on both of these. On 5 here, we're just going to do this, cosine of 0.33. So on our calculator, I'm going to hit 0.33 first, and then hit the inverse cosine. So inverse cosine, and it's 70.7. So approximately 70.7. This one, it's going to be the inverse sine of 0.89. So then on my calculator, I put 0.89, hit the inverse. Oops, that's not the inverse button. What did I say? 0.89 inverse, and then we're doing sine. So inverse of sine is this, 62.9. It's approximately what we see. So the measure of angle H on this one is 62.9. So that's just learning how to actually just use the calculator to be able to calculate the inverse and figure out what the angle measure of. These are, if you're given what the ratio would be. So this is the ratio. The sine, which would be opposite over adjacent, opposite over hypotenuse, would be 0.89 as you do that. And so then you could figure out what the measure of the angle is. Okay, so on the top of page 270, we see our other core concept. Here you can just highlight solve a right triangle. That's the other vocabulary. It says that to solve a right triangle, it means to find all unknown side lengths and angle measures. We've done this before where we've solved triangles in the past. We've found all the angle measures and all the side lengths of the triangle. It says you can solve a right triangle when you know either of the following. So specifically for a right triangle, if you know 2 side lengths, you could solve a right triangle because you could find the third side length with Pythagorean theorem, and then using the inverse trig ratios, you could find the other 2 acute angles. We also could solve a right triangle if we know 1 side length and the measure of one of those acute angles, because then we could use, obviously we can get the other acute angle with just the triangle sum theorem, because they all add up to 180. And then for the side lengths, we can figure out the other side lengths with the trig ratios as well. So we can do the trig ratios. Eventually we can use Pythagorean theorem to find the last side length. So we can still solve a right triangle if we just know 1 side length and 1 acute angle measure. Okay, so now we're going to solve 2 right triangles here, 7 and 8 on page 271 for extra practice. Solve the right triangle. Round decimal answers to the nearest tenth. So 1 decimal place. So on both of these, they give us that first condition, we have 2 sides. So if we have 2 sides, then we want to start to solve the right triangle. We need to find the other side length. So in this one, number 7, we need to find the length of AC. And we also need to find the measure of angle A, and we need to find the measure of angle C. So let's start with just finding this third side of AC. So I'm going to just put a little X right there. We're looking for X on this one. And so using Pythagorean theorem, we can find that. A squared plus B squared equals C squared. And so in this case, X is the C squared. X is the hypotenuse. So here's your A squared, your B squared. So 6 squared plus 12 squared will equal X squared. So that's what we're going to be doing here. And so we're just going to work this out. So this is going to be 36, 144. So 36 plus 144 equals X squared. Add those together, we get 180 is equal to X squared. Now we just want to take the square root of both sides to solve for X. So we're looking at X is equal to the square root of 180. We can do that on our calculator. It's really quick. 180 and hit the square root button. 13.4 approximately right there. So that's going to be 13.4 for that other side length. And now we want to find the acute angles. So we got to just pick one of them to start with. It doesn't matter which one you start with. And we're going to use trig ratios to do this. I'm going to start with angle A on this one. So angle A, if we're looking for A, we're going to have to use the inverse trig ratio. And you can, since we know all 3 sides, it really doesn't matter which one you choose. You can choose sine, cosine, or tangent because you know all the sides at this point. But for me, I'd probably just choose the 2 here that are whole numbers, 6 and 12. And so that would be considered the tangent then, because we have for this one from A, opposite is 12 and adjacent is 6. That's opposite over adjacent. So 12 over 6 would just be 2. So it's the inverse tangent of the 2. 2 is the trig ratio on that one from 12 over 6. So now we would just use our calculator to do this here. So I'm going to just put in 2 and then inverse tangent, and so that's going to give me 63.4 for the angle measure for A. So that tells me 63.4 degrees. And so now I need to figure out C, and C we don't have to use any more trig ratios, because if we know this is 90 degrees, these two, A and C, will add up to 90. And so to find angle C, we can just do 90 minus the 63.4, and that's just done quickly. You can use a calculator if you want to, 26.6 degrees. So there it is, the triangle is solved. So go ahead and try now this one, number 8. See if you can do the same thing. Use Pythagorean theorem to find ED here. So you can put a little x down here, which is going to be, here's your hypotenuse, so a squared plus the x squared is the 75. So go ahead and start there and find the side length, and then go ahead and try to find the acute angles of A or C and D on this one. So go ahead and stop the video and try number 8, and then start it again. See if you can do this correctly. Okay, so hopefully you did try number 8. And to find out this ED side, I'm going to put a little x there just to say we're going to see 21, or x squared. You can say x squared plus 21 squared is equal to 75 squared. And then we can do 21 squared is 441. 75 squared is 5,625. Got to subtract 441 from both sides. So now x squared is equal to 5,184, and take the square root of both sides. So now we want to figure out here, what's the square root of this 5,184? Do that real fast, 5,184, hit the square root button, it's 72 exactly. So answer for x is 72. And now to figure out, you got to pick one of those two. It doesn't matter which one you start with, C or D. See, I started with C on this one, so I'm going off of C. And again, it doesn't matter even which trig ratio you use, because you have all the numbers. They're all, in fact, whole numbers, so it really doesn't matter. You could have chosen a different one than I'm choosing and still get the answer right, just as long as your answer is correct for angle C. So I'm choosing the cosine, which if I'm going to choose the cosine, that means I'm going to choose adjacent over hypotenuse, which is the two numbers that I was given, the 21 over 75. So 21 over 75. So I'm going to do that on the calculator. I could even do this. I could say 21 divided by 75, like that, equals 0.28, and then hit inverse and cosine, and there's my number, 73.7. So 73.7 degrees is angle C, and then the other angle, you do the same thing like we did over here, with just 90 minus that 73.7. So 90 minus 73.7 is 16.3. And now this triangle is solved. Alright. So let's do a little joke of the day. We'll take a little thing. What does a nosy pepper do? What does a nosy pepper do? It gets jalapeno business. Jalapeno business. Alright, that's always a fun one. Okay, so for 9 and 10, we're still looking to solve the right triangles, but now we're doing the other condition where we're given one side and one angle measure, one of the acute angles. So there's our right angle. We're given one of the acute angles here, and we're given one side length. So we can solve this with those conditions as well. So the first thing on this one I would do is it's easy to find the other angle measure because we know those two add up to 90. So we could just do that one really quickly. 90 minus 52 is going to give us 38. So our angle measure there is 38 degrees for angle N. And then we want to figure out these two sides here. We're given a 3 on this side. That's the hypotenuse. So now we're going to use trig ratios. We can go off of 52 degrees if we want to. We could even go off of 38. Doesn't matter. So I'm going to do the sine of 52 degrees. So if I'm using sine here, that's going to be, looking for opposite first. I'm looking for this one first here, the MN side, and so that's going to be x over 3. And then to solve this, we need to multiply basically both sides by 3. So it's 3 times the sine of 52. That's what x will equal. And then we can just do that on a calculator. We can say the 3 even right now. Let's see, let's go and clear this. I could say 3 times the 52 and then sine of that and then equals. So that's about 2.5 let's round it to one decimal place like they said, so that's 2.4. So x would be 2.4, so that MN side is approximately 2.4. And then to find the other side, we can do the cosine this time, which would be adjacent to 52, using 52 again. Adjacent to 52 over hypotenuse. So I'm going to say y for this one, so it's not the same as x. So multiply this by 3, both sides by 3, so 3 times the cosine of 52 degrees equals y. So I'll do the same thing on my calculator. 3 times the 52, I'm going to have to type 52 in first, and then the cosine, so just cosine button, and then equals 1.8 looks like is what we have. So 1.8, so side LM is 1.8. Now if we were using this calculator in class to be able to do what I just did on the calculator, you could hit the 3, the times button, and then you would just hit the cosine or the sine button, whichever one you're doing, cosine, and then you put 52 in for the degrees, close the parenthesis, and then you hit equals. And so that's how you can do it on this calculator. Okay, so number 10, go ahead and try number 10 and see if you can do this one, and then start the video. So pause the video for a minute and try it. Figure out the angle measure first, then figure out the side measures, and then see if you get that right. Okay, so hopefully you did finish number 10. Let's go ahead and figure out what y is here. The measure of angle y, we know 29 is up there, so it's just 90 minus 29. That's quickly 61 degrees, so the measure of angle y is 61 degrees. And then we want to find these other two sides. I'm going to use A and B, so I need to find this side here, which is from x to z. I'm just going to call that A right now. And I'm also going to find y to z, which is the hypotenuse. I'm going to call that B right now. So as I'm plugging these in, so I'm going to use the 29 degrees to find these two. I'm going to have to use 18, of course. So that's opposite over adjacent for A, which would be tangent. So I can use the tangent of 29, which would be 18 over A, opposite over adjacent. And then that means I'm going to have to switch both of these. Remember, when you variables at the bottom, you can just switch them. So A is equal to 18 divided by the tangent of 29. And so we can do that on our calculator. So I can just hit 18 and divide it by 29, and then the tangent, and then equals. So that's 32.5. I round that up. So 32.5 is our A. So A is equal to 32.5 on this one. And then for the B, if I use 29 again, it's going to now be opposite over hypotenuse. So that would be the sine of 18 over B. So sine of 29 degrees is equal to 18 over B. And again, go ahead and you switch both places here. So B is going to equal 18 divided by the sine of 29 degrees. And so on our calculator, we would then hit 18 again first, and then divided by, 29, and then this time the sine button, and equals, it's 37.1. Now this one we would leave alone, we don't round that one up, just leave it at 0.1. So 37.1 is our answer for this side. So that's now solved. We found all the angle measures, we found all the sides, and that's it, we're good. Okay, so our last little problem here, number 11, with this boat. It says a boat is pulled in by a winch on a dock 12 feet above the deck of the boat. When the winch is fully extended to 25 feet, what is the angle of elevation from the boat to the winch? So the winch is up here, both down here. We're basically looking for the angle of elevation, which is this angle right here, this acute angle. We know this is going to be a right angle because we have the dock is going to be straight up. This is the shore, or the sea right here, which is going to be a horizontal. That's definitely a right angle. So we're looking for what that is. So I'm going to just put a little x degrees there. So we know this is 12 on this side. We know this is 25 from here to here, which this would be the hypotenuse. This would be opposite, so opposite and hypotenuse. That's going to be our sine. So for x, we're going to have to use the inverse sine to find the angle measure. We know the sides, we need to find the angle measure, so we're going to use the inverse of the sine. So inverse of sine of the ratio, 12 over 25. And so then just to do that on the calculator, we would hit 12 divided by 25, and that equals a decimal of 0.48. We would then just hit inverse sine of that. So I'm going to hit the inverse and then the sine button and equals. So oops, I think I did that incorrectly. Let me try this one more time. So it'll be 12 divided by 25, which is 0.48. So 0.48 and then inverse and sine. There it is. I don't have to hit equals. I hit equals too many times. So once I hit equals, I get my answer there. 28 point. If I go to one decimal place, which it didn't say to, but I'll just go there one decimal place. Anyways, that'd be about 28.7. So you can see right there, 28.7 degrees would be our angle of elevation. All right, so that concludes 9.6. Go ahead and continue on with the assignment and complete that, and I'll see you back in class.